Right, hey everyone, welcome back to A-Level Lessons Online. Okay, we're back with more of our A-Level Math. Okay, we're going to be covering H2 Math again today. Moving on to question 4 of your 2017 paper 1. Okay, so question 4 is actually, once again, so far the first 3 questions have been extremely easy. And question 4 is no different. Okay, question 4 is also one of the easier questions of this paper. Okay, you're going to be looking at a combination of differentiation as well as graphing techniques. Okay, this question, go ahead and try it first, okay, if you can, before you actually look at this. I'm going to go through it now. Okay, it's actually very simple. So what I've done is on paper, I've actually, before I took a photo of this question was, I wrote down a very simple formula that you need to make sure you remember for your product rule, okay, of differentiation. So the product rule for differentiation goes like this, as I'm highlighting over here. So for product rule, just very simply, you always use differentiation you always use product rule for differentiation, okay, when you have a fraction. So the top part is usually the u and the bottom is the v. Okay, so for this question, part 1 asks you to show that the gradient of c is negative for all points on C. Okay, so when it asks you to show the gradient of something, okay, and they give you an equation y equals to x, okay, it means that chances are you're going to have to find dy dx. Okay, there's no other way of finding that gradient m. Okay, so for this first part, it's very, very simple, just product rule differentiation. That's why it's only 3 marks. So I'll just do it right here. Okay, you can follow along. If you don't understand or anything, leave a comment down in the bottom. Okay, I'll answer it. So part 1, okay, y equals to 4x plus 9 over x plus 2. So the top part will be a u and the bottom will be a v. Okay, so when you differentiate this in your terms of product rule, you just need to follow the formula. You have dy over dx equals to v first, okay, which is x plus 2, right? Okay, then du dx. So you differentiate the top, okay, you only get 4. Then minus u, which is 4x plus 9. And then you differentiate the bottom, so you have 1. Okay, over v squared. So it is just x plus 2 whole thing squared. So all you need to do now is just expand it. Okay, what you will get is 4x plus 8 minus 4x minus 9. Okay, and this will be over x plus 2 whole thing squared. Okay, once you have done this, then you just need to combine everything together. Your answer will very simply be negative 1 over x plus 2 whole thing squared. Okay, so since your dy dx over here is a negative 1 over x plus 2 squared, okay, if your x value is anything, okay, be it a negative or a positive, okay, in the bottom, I'm looking at the bottom over here, right? If it is a positive x value or negative x value, okay, you realize that the answer will always be a negative, okay, a gradient will always be a negative, okay, because the bottom, let's say even if it's negative 100, okay, plus 2, as long as you square a negative number, you still get a positive number. Okay, so no matter what, this part over here will always be a positive, and as a result of the negative sign that is before, okay, this whole dy dx will always be a negative. Okay, so your answer will be something like this. Since dy dx, which is equivalent to negative 1 over x plus 2 squared. Okay, if you want to put in your inequalities way, you'll just put less than 0 like this. Okay, it means that it is always negative. Okay, for all real values of x. Okay, it's always for all real values of x. Okay, because like the question is asking, okay, for all points on C. Okay, so you're looking at every single value of x. Okay, what happens is, comma, the gradient or the dy dx, okay, the gradient, in this case they're asking the questions worded it as gradient, is negative for all points on C. Okay, and that very, very simply is going to be your answer there, finished. Okay, so part 1 is very, very simple. Okay, I won't dive any deeper, okay, because I think it is very, very straightforward. Okay, part 2. Okay, also a very, very simple part. Okay, by expressing the equation of C in the form of y equals to a plus b over x plus 2, where a and b are constants, write down the equations of the asymptotes, okay, of C. Okay, this one is a question that you need to learn how to answer. Okay, it's a skill. Okay, this one you're always going to be looking when you want to express something in this form over here, y equals to a plus b over x plus 2, and they're asking you to find the asymptotes. Okay, firstly you have to recognize that the first asymptote is definitely going to be x equals to negative 2. Okay, and then your other asymptote will very simply be y equals to a. Okay, that is the reason why they're asking you to express it this way. So what we're going to do is we're going to perform long division, okay, because that is the only way to actually get this, okay, from your curve equation C, okay, because the degree is the same for the x value in your denominator and your numerator. Okay, so if I were to do long division, this is back to primary school stuff, okay, you're going to write in here 4x plus 9, okay, divided by x plus 2. So firstly, you take the 4, you minus the 4x, always put a bracket first. Then you take the 4 times 2, you get 8 plus 8 over 1. So 9 minus 8 will just be 1. And that's actually all. Okay, so now all you need to do is just combine this into your, formulate it in the way it's supposed to be done, which will be y equals to 4 plus 1 over x plus 2. So the remainder will always go on top. This is your remainder. Okay, and this part will be the quotient. Okay, the answer that you got at first. Okay, so that is how you will get it. Okay, and hence your asymptotes are very simple. Your answer is very simple now. You've got y equals to 4 and x equals to negative 2. Okay, so to find your x asymptote, okay, all you need to do is this bottom part over here. You just let this equals to 0. Okay, you'll find that x equals to negative 2. This is one asymptote, and this part before the x portion, okay, will be your other asymptote. Okay, so that is all for this part 2. Okay, the last part C, is the slightly trickier part, okay, for some of you, okay, because you may not exactly understand transformation. So this part they're asking you, okay, to describe a pair. Means there are only two lines, there's only two different transformations, okay, which transforms the graph of C onto the graph y equals to 1 over x. Okay, so what you want to do for this part is to just work it out slowly, okay? So we'll get from, in order to get from step 1 to step 2, okay, your curve equation C is y equals to 4x plus 9 over x plus 2, correct? So you're trying to get this to become 1 over x. Okay, so how are we going to do this? Okay, work it out step by step, okay, slowly. Okay, firstly, you will notice that in order to get somewhere near 1 over x, you will have to use something. Okay, and that's the whole reason why there's part 2. Okay, part 2 already asks you to express in this manner, right? Y equals to 4 plus 1 over x plus 2. So we're going to make use of that. Okay, so y equals to 4 plus 1 over x plus 2 was what we got from part 2. Okay, so from here what you can do is you can actually start to transform this into the curve that you want, which is 1 over x. So what we're going to do is we're going to try and get rid, okay, we want to get only x in the denominator over here. So we're going to try and make this part x plus 2 to just become x. Okay, and what you're going to do is you're going to say sub x to become x minus 2. X to x minus 2. Okay, because the reason why x minus 2 is so that we can actually get rid of the 2. Right, so x minus 2 plus 2 will get you just x. So this would get you y equals to 4 plus 1 over x minus 2 plus 2. So that is really your first transformation. Okay, so this means x minus 2 will basically means a positive x direction by 2 units. Okay, so 2 units in positive x direction. Okay, this one you have to know, right? This one is based on your content. Okay, you should know already. Okay, and then so now that we've got this part, you will just be left with y equals to 4 plus 1 over x. So now in order to just get y equals to 1 over x, what do we need to do? Okay, we need to find a way to get rid of the 4. Okay, and how we're going to do that is you're just going to simply take everything minus 4. You'll get y equals to 4 plus 1 over x minus 4. Okay, and this would mean that you're going to be left with y equals to 1 over x. Hence, this y minus 4, okay, because in order to get minus 4 on one side, you have to minus 4 on the other side as well. Okay, it means that you are going to translate again by 4 units in the negative y direction. Okay, the reason being is because in order to get a minus 4 over here, you need to take y minus 4 equals to 4 plus 1 over x minus 4. So this was the transformation, y minus 4. So hence, your answer, okay, would very simply be translate. Translate means to just shift the curve, okay, by along that axis. C by 2 units in the positive x direction, okay, because it was a x minus 2, okay, as well as to translate C by 4 units in the negative, okay, because of y minus 4, y direction. Okay, and so this will be your answer in order for you to get the full marks for this question. Okay, so if you did enjoy this video, okay, be sure to give it a thumbs up. If you have any questions, okay, I know this question for some of you may be a bit trickier, okay, because you may not be like super clear on what transformation is and anything with regarding to your product rule of differentiation. So if you have any questions, leave it in the comment section below. Okay, I will answer it as well. If not, yeah, if you did enjoy this video, okay, do be sure to subscribe. It really does help me out a lot, as well as to leave a like. Okay, also does help me out a lot as well. Okay, so if not, I'll see you guys in the next question, question 5. Till then, have a good one. Bye bye.